All right, this is the introduction for this class. Normally this would be done as a discussion, and I would actually do something a little bit different, but with times the way they are, this is just kind of the idea to get you thinking. Normally it goes much better as a discussion in class where we can be together, but well, it's not now. So what you're looking at here is, we're focusing on this table to start. What we have is a bunch of time frames. It's timing out every half hour for 3 hours, and we're just pretending we're going on a car trip. And you're keeping track every half hour. Look at how many miles you have gone. All right, and I've just graphed that data up. So we'll go back to the graph, but let's focus down at the bottom. Question is, what is the average rate of speed for the time frame? Okay, what we're doing with this is kind of like the idea that we're going to be focusing in on for majority of the year for calculus. And this kind of gets at the heart of just what it is. But this is a really basic question. So, what is the average speed for this time frame of the entire trip? Okay, key phrasing is right here. Average rate of speed. So what I really want you to do is I want you to hit pause on the video and try to answer those 3 questions. All right, now hopefully you got them. But the idea here, average rate of speed, the whole trip. We did a whole trip in 3 hours, but we covered 138 miles. When we talk about a rate of speed, when you think about your car or vehicle, how fast you're going, you think about miles per hour. So when we write that as mph, that per is really the number of miles divided by the number of hours. So for the whole trip, we did 138 miles in 3 hours. So 138 divided by 3, we get 46 miles per hour. Now, does that mean you started this trip, hit cruise control right at 46 and stayed there? No, really. And so that's the idea of this average rate of change. If we go to the graph, if we start at 0 and go to the end, when we talk about an average rate, what we're talking about is just the slope between those 2 points. Here is the start. We did 0 miles at a time of 0. Here's where we ended at 3 hours. This 46 would be the slope of that line. The next part of the question, what is the average rate of speed for the last hour? So the last hour, we went from 104 miles to 138 miles. So that means we did 34 miles, but we did it in 1 hour. So that is 34 miles per hour. Now again, does it mean that we went 34 miles an hour for that entire hour? No. Obviously, we're changing speeds. The whole trip, we averaged 46 miles an hour. The last hour went 34. So it seems like we're slowing down for that last part of the trip. So the idea here, this 34 number, for that last hour, if I go up to my hour 2 point, to the end point, and I place my ruler there, what we're talking about is this 34 is the slope of that line. It is an average rate of change. Okay, so you can see how this slope has changed. There's the whole trip. There's the last hour. So it's a little bit less of a slope. And we can tell that we're slowing down because if I kind of add another question, if we go to this first hour, you can see this, or first half hour, you can see the slope is a lot steeper. But we also, in the first half hour, we did 30 miles in half an hour. So if you kind of carry that out, that's really a slope of 60 miles per hour. And so we're going real fast in the beginning, going faster in the beginning, and then we seem to be slowing down towards the end of the trip. Okay, for the last half hour, so I'm going to go to my last 2 points. Look back at the chart. In this last half hour, we went from 104 miles to 138 miles. So we really only did, what is that, 14 miles, but we did that in half an hour. Now, I'm going to expand this out a little bit. And I know it's kind of down at the bottom of the screen, so let me try to move this up for you. We did 138 minus the 124. That gave us our distance that we covered. We did hour 3 minus hour 2.5. That's where we're getting our 14 over a half. Now, this should look very familiar to you. It is really just slope, the difference in our y values divided by the difference in our x values. When we do this, 14 divided by half, we get 28 miles per hour in this context. So again, you can see that we're slowing down. All right, so there's the 28 number is the slope between those last two lines. Okay, now the gist of this calculus class, what we're trying to get to with this summation. What if I added another question to our list here? What if I wanted to know how fast were we going at this one instant? Not just an average over this bigger time frame between a couple of points, but at one instant. So if you look at what we did in the sequence of these three questions, we went from this line connecting these 2 points that are fairly far apart, going to the line connecting those 2 points for that last hour. Then, for the last half hour, we went to the slope between those 2 points. So if I change the question to how fast were we going at this one instant, right at the end of our trip? Okay, we know we were slowing down. We were going 60 miles an hour on average for the first hour. In the first hour, we were going 55 miles an hour, and then we got 34 miles an hour, then we got 28 miles an hour for that last half hour. So we know we're slowing down. But the question is, how fast are we going at this one instant of this last time frame? Okay, now, I don't expect you to know the answer, but again, this is just kind of the idea of where we're going with this material. Talking about slope. When we look at this bottom calculation here, that is just slope between 2 points, but it was average. So the question is, how fast are we going at this one instant? Now, you cannot find the slope at a single point. That's fine, but this is what calculus is going to do for us. So the idea of how fast we're going at one instant, we took a slope between two that are far apart. Not a good answer, 46 miles an hour. That's not how fast we're going here, because we're only going 28 miles an hour in that last half hour. So not a great answer here. So let's bring those 2 points closer together. Between the last hour, we set the slope between those 2 points. Notice how these points are closer together compared to all of this. Not a great answer also. 34 miles an hour for that last hour. Okay, so let's bring these 2 points closer together. So for the last half hour, 28 miles an hour. It's a better answer, but is it great? No, we're slowing down. And so what we can do, what calculus is going to do for us, is to find the slope. Again, in this context, the slope is the miles per hour. We're going to keep on bringing these points closer and closer together. Now, again, you cannot find the slope at one point. You can find the slope between 2 points. But if we keep on bringing these closer and closer together, where that distance between those 2 points becomes so small that we can't even tell that there's a difference between them, that's going to give us the slope at a certain point. It's the idea of a tangent line. Okay, I know this is going to be really confusing. Don't worry about it. This is what we're going to be talking about throughout the year. But this is kind of the big idea of what's called a derivative. Slope between 2 points is an average. We want to get a slope at a single point, and so what we're going to do is bring those 2 points super close together so that we can't even tell that there is a difference between those 2 points. But we can still find the slope between 2 points. They're just really, really close together. It's going to give us this idea of how fast we're going at one instant. So, again, this kind of works a lot better as a discussion in the class, but that's not possible for most of us or a lot of us, so this is the idea. Again, don't worry. We're going to cover this in class. It'll make a lot more sense as we start going through things and building up this system of calculus. So I hope this helps. Bye.